Hello everyone, welcome to Let Us Code. Today is day 14 of March for the daily lead code challenge, and let us see what kind of question it is. It's a medium level question, question 189, some root to leaf numbers. So see, before reading the question, let me tell you, this is a tree structure. This is the class which is being implemented, tree node class. So each node in this will have a left pointer, will have a right pointer, at the same time will have a value pointer. Value, and this is a value, not a pointer, just a value. Whatever the value is made as 0, and the pointers are made none. None and null are like similar, but in null we use in C++ and none we use in Python. Okay, I will solve this in Python first of all. So coming to this sample, the example one, as you can see, we what we have to do is I will quickly tell you that. Suppose I'm starting from one and coming down to the leaf. Leaf is the one which don't have a children. Okay, one has two children, two and three. Two do not have a children. Similarly, three do not have a children. So two and three are leaf nodes. So when I come down, I will come from one to two. So 1 and 2. So if we make them as a number, it will be 12, right? Similarly, if we come from 1 to 3, and 3 does not have anything further, so the number will be 13. Okay. Now we have to add the path. That means 1 to 2, 1 to 3. So we'll get 25. So what the question says is that you are given a root of a binary tree containing digits from 0 to 9. So this will be always singular digits that won't have a value greater than 9. Each root to leaf path in this represents a number, okay, as I told, 0 to 9. In this example, as you can see, yeah, suppose so they are seeing an example of 1 to 3. If so, in this case 1 2, and suppose one more number 3 is there. In this case, for example, 4 9 and 5, 495 it will be. Then the total sum of all root to leaf numbers. So sum of all root to leaf numbers. Read this line very carefully. Total sum of all root to leaf numbers. For example, in this case, the example 2, first will be 495, as you can see here, 495. Next will be 4, then 9, then 1. So it will be 491. At last 4, then 0. So it will be 40. So I have to add all the three numbers here, 495, 491, and 40. Sum of all, see here it's written, total sum of all root to leaf numbers. Okay. And seeing the complexity, it's not a very big range they have given. Okay, this we already know, 0 to 9. And the depth already won't be exceeding 10. That was a good one. So coming to the coding of it. So I will try to keep it very simple one, because it's a medium level question and the depth is, see, it's not 10 to the power 5 or something like that. That's why we need not worry much. I will be going for a DFS solution, a simple DFS solution. First of all, let me declare the answer. This is the answer variable which I will be finally returning. So at last I will be returning the answer. Okay, this value instantly is initialized with 0. Then I will be defining my DFS function. At the same time I will be declaring this variable. I will tell you what it is. Okay. So because answer is after of this, so I have to make it as a non-local one. Finally, because see, if the left is not none, only then I will be sending it. Because see, if the left is none, I can't do it. So I will just code it first, then I will let you explain. Same logic for the right one. So it is left here, it is right here. So like this will be continuously going. So where to stop, the stop condition will be if both of them are null. Okay. So for example, in this case, this particular node does not, for example, the node 1 in this case does not have. So for leaf nodes, this is the condition for leaf nodes. Okay. If root dot left is equal to none and dot none. In this case, this will be implemented. Okay. If this is the case, What we'll have to do is like we will be simply adding it to the answer. Okay. The int of we'll explain with the example also. First, let us see if it works. So, see, in this case, in all of the cases, uh, see, with the second I'm entering, I'm checking if root dot left is there or not, root dot right is there or not. So, I have to ensure that the value like, sent to this function does not have a none value. So, I will do if root is equal to none and 0. I've not made the function call till now. So, it will be simple dfs root. Let us see if it runs correctly. Okay, my bad. Rest all seems to be correct. So yeah, it's clear in the rest cases. So let me quickly explain you how it works. I am at 4, okay? I'm at 4. This so when I'm calling this DFS, it will come here. Initially the L value is 0. It means it's like empty string. Then when I'm sending it, I'm sending it with L. Okay? With L and I'm appending the root value. So by the time it comes to 9 and 0, so by the time it comes to 9 and 0, L will be 4, okay? With 9, it will be added to the L. So by the time we come to 5 and 1, it will be 4 and 9, okay? And by the time we go below that, it means when the leaf condition is reached, what I will be doing is the L which we have till now, which is 4 and 9 in this case, and I will be appending each of the individual leaf node value, which is 5. So 4, 9, 5, it will become 4, 9, 1, okay? And similarly, 0 is also a leaf. So what I will be doing is I will be adding 4 as well. 4 is coming already, and I'm adding 0, it will be 14. So for each of them, I'm adding it to the answer variable. As you can see, answer is a non-local variable here, which means it is referring to this one. So it will be concurrently adding to answer variable, and finally we get the answer of all the nodes. So let me quickly run this and show you. So yeah, it is accepted. So see how to think this logic. So whenever we are going down the route, from root to down the leaves, it should be a DFS solution. See this question, if we do it in BFS, it will be harder in my way of thinking. Okay. And one much more important thing is all test cases will be fitting inside the 32 integer range. That's why I'm using the integer. If this doesn't fit, I will have to maybe use a float variable to show the answer. Finally, for returning the answer, I will have to cast it to an integer. But since they have assured me that all of them will be within the 32 integer range, so I am good. Coming to the analysis of it. So see, ultimately we are going down and coming up for each of the edges and the nodes. So the time complexity will be O of n plus c. Come to the space complexity of it, I am not using anything other than a simple answer variable. So it should be of 1. So this is the time complexity. This is the space complexity. See, when we say O of n plus, it doesn't mean only single time I'm going and coming. It can be any number of times. For example, in this case, I'm going from 1 to 2. I'm crossing this edge once. Then I'm returning back. Because usually you can see, we are returning from here, okay? This function will be returning like a stack initial tag will be used and it will be returning. So I'm returning back to 1. Similarly, it will go to 3 and return back to 1. So for each node, it should be 2 into n plus 2 n plus 2e. But because we are using the notation, it should become O plus O of n plus e, okay? So yeah, that's all for today. Thank you. If you really like the video, please like and subscribe. Thank you.